ever seen a night sky and wondered how did the stars come alive? But did you also know that every single star that you see in the night sky are going to die one day? How? Let's see. Hello everyone, welcome to Geography with Isha. Now in our previous episode we talked about a Big Bang explosion which resulted in the formation of the first atoms, hydrogen and helium. Now if you didn't watch that video, I'll put a video link in the description below. You can go and watch the video. Now after the Big Bang explosion was also the formation of a large group of dust and gas known as nebulae. Now millions of years after the Big Bang, this large group of dust and gas or the nebulae with the hydrogen atoms present started to fuse together due to strong gravitational pull to form into something known as a protostar. Now a protostar is a high pressure body. This is also how a star is born. Now inside a protostar there is a constant turning of hydrogen into helium under a process known as the thermonuclear fusion. Now this thermonuclear fusion results in high radiation pressure. Now this radiation pressure is so strong that it wants to go outside, but there is also a strong gravitational pull which pulls all this inside the star. So inside a star there is two forces which is constantly battling to find a balance, and these are the strong gravitational force and the strong radiation pressure. Now the nebula from which a star is born is known as a stellar nebula. So now you know that hydrogen is required to keep a star alive. So what will happen when a star runs out of hydrogen? It's just like how we put petrol or diesel in our vehicle. When our vehicle runs out of petrol or diesel, it will not work. Similarly, what will happen when a star runs out of hydrogen? It will simply die. Yes, a star will die, and there are three possibilities when a star dies. It can either become a white dwarf, it can either become a neutron star, or it will become the most interesting one, a black hole. Now this depends on the mass of the star. So what is a mass? Mass is nothing but the amount of matter inside an object. Now you should not confuse mass with weight. Weight is the actual heaviness of the mass, or it is the force with which all the mass is pulled down. But mass is nothing but all the amount of matter inside an object. Now stars range from low mass stars to large mass stars. Now our sun is a star. Yes, our sun is a star, and we can only imagine the kind of reaction going on inside a sun, because even though our sun is so far away from our earth, we can still feel the heat and the light from the sun. Now you might be imagining that okay, if a star is having low mass, then it will have less hydrogen and so it will die easily, and a star if having a large mass will have more hydrogen and so it will live for a longer time. Well, it is the exact opposite. How? We'll see. Now before understanding how a star dies, we should know something known as the Chandrasekhar Limit. Now the Chandrasekhar Limit was given by an Indian American astrophysicist called Subramanian Chandrasekhar in 1930. He said that he predicted the Chandrasekhar Limit to be 1.44 times the mass of Sun. That is, if any star which has a mass less than 1.44 times the mass of Sun will become a white dwarf, and any star which has a mass 1.44 times the mass of Sun or larger than it will become either a neutron star or a black hole. Now Chandrasekhar Subramanian also got the Nobel Prize for Physics in 1983. So how does a star die? Well, from a protostar there can be low mass stars, there can be medium mass stars, or there can be very large massive stars. And when these stars run out of hydrogen, they will expand. Why? Because they are trying to get as many hydrogen as possible to keep them alive, and in the process they will expand to a very large size. And if this star had a mass less than 1.44 times the mass of Sun, what will happen is that this star will become a red giant, that it will swell up. and that red giant will run out of hydrogen, which will turn into helium, and the helium will turn into carbon, and then it will turn into oxygen, and then what will happen is that this red giant will collapse. In the process it will become a white dwarf. Now white dwarfs are dim, they are condensed or dense form of this star, and since they do not have any hydrogen in them, they will not form any reaction, and so they will not have radiation pressure, but there will be still gravitational force which will be keeping them together. And this white dwarf after billions of years will become something known as the black dwarf. Now what will happen if this star was larger than the sun? Then what will happen is the same thing will happen. These two stars, the medium stars and the large massive stars, will also become red giants. That is, they will swell up, but because of their massive size, the hydrogen will turn into helium, the helium will be turning into carbon, the carbon will turn into oxygen, and then under high pressure and temperature this oxygen will turn into neon, and this neon will be turning into silicon, and this silicon will be turning into iron, and when the core of the star becomes iron, it cannot fuse anymore, it cannot burn anymore. So what will happen? This has expanded, right? This has become a red giant. Now what will happen is, boom, there will be a huge explosion, and this explosion is known as the supernova explosion. Now this supernova explosion from an astronomer's perspective is a very crucial thing. This helps in ejecting out metals. So the calcium in our body, the iron in our body, or all the elements that we see on earth might have been due to a large explosion of a star billions of years ago. So fun fact, we were actually a part of a star. So the supernova explosion. Now this is a huge explosion, and this also results in furthermore new nebulas or new clouds of dust and gas, which can result in new formation of stars. But there are two possibilities once the supernova explosion happens. If the mass of the star was say 5 to 10 times the mass of sun, then what will happen is that it will collapse into something known as a neutron star. Now neutron stars do not produce any light of their own, but they are very fast rotating stars and they produce high electromagnetic waves in them. Now what if the star was a very massive star? What will happen to this after supernova explosion? What will happen is that this massive star will condense into a very dense object. Now to understand this, imagine you have a large piece of paper and you weigh it and it is say 1 gram. Now you try to push it down, you try to make a ball out of that paper. Now this paper was a large paper, but now it is of small size, that is all the matters are tightly packed in it. But if you weigh the paper again, it will be still 1 gram, that is the mass will not change. Similarly, after the supernova explosion, there will be a strong compaction of the nova which will result in a black hole. Now what is a black hole? A black hole is a very dense object with strong gravitational pull. It is said that whatever crosses the black hole will never come out of it. And now if you want to know more about black hole, I can make a video on that. Please do comment down if you want a video on black hole. Now you have understood how a star is born. Let's recap. So a nebula called the stellar nebula fuses with the hydrogen to form protostar. Now from this protostar there can be low mass stars, there can be medium mass stars, or they can be high mass stars. And the low mass stars will eventually become what is known as a white dwarf, and then after billions of years it will become a black dwarf. But high mass stars, they will become a red giant, and after supernova explosion they will either become a neutron star or a black hole. Now let us answer some questions. Question number 1. Why do some stars do not shine with the same intensity? Well, there are two possible reasons. One is the distance difference, and another one is that the brightness of the star depends on the age of the star. Now distance. If a star is very far away from our earth, then it will be not as bright as a star which will be close to the earth, and also the age of the star. Now if a star is young, it will be more bright and blue, and if a star is old, it will be less bright and reddish in color. Now second question, which is the brightest star outside our solar system? The brightest star outside our solar system is known as the Sirius star or the dog star. Third question, which is the closest star to our solar system? The closest star to our solar system is the Proxima Centauri. So the fourth question, how will our sun die? Well, our sun is a star, so it will eventually die. Scientists predict that our sun will die to become a white dwarf because it is less than the Chandrasekhar limit. When will this happen? It is said that the sun will have an age span of about 9 to 10 billion years. Right now, our sun is about 4.5 billion years, which is the same age as our earth. So we don't have to worry about it because we have 4.5 more billion years till the sun dies. Now, fifth question, what will happen if the sun becomes a black hole? Now, the sun cannot become a black hole because it is less than the Chandrasekhar limit, and it will become a white dwarf, and after billions of years it will become a black dwarf. But let's imagine that our sun becomes a black hole. It's interesting that even if our sun becomes a black hole, the gravitational pull of the sun will be the same as it is now, and so all the planets will be revolving in the same orbit. But without a large star like our sun, our earth will not have light or heat, and eventually our earth cannot have life. Now I hope you have enjoyed this video, and I hope that you know how a star is born and how the death of a star occurs, and if you have any doubt you can put it in the comment down below and I'll try to answer it as much as possible. And please do like my video, share this video with your friends and family, and please do subscribe to my channel for more such videos. And thank you for watching. I'll see you in my next video.